Jai Bharat to all students. In last lecture, we have discussed how to solve puzzle using graph theory. Okay, in that we have discussed three different types of puzzle. Okay, and simple how to solve puzzle using graph theory. Okay, in that we have solved 8 circle problem, 6 or more party in the people who know each other, then cube problem. Okay, so this is a difficult problem if we know will not use the graph theory, but with the help of graph theory we simply solve these types of puzzle. Okay, so it's very important. Okay. So now in today's lecture we will start with our new chapter, tree. Okay, we already discussed what is tree basic in first or I think second lecture. Okay, so we will start with the tree, and we will talk about different types of tree and its related theorem, different theorem. Okay, okay. So first of all, what is tree? We already know that tree has a, if tree has a not has a cycle. Okay, tree in graph, if there is a no cycle, then it's called a tree. Also in graph if graph all the vertex should be connected means like this. Okay, if this is a one graph they have given, but if we connect these two vertex, so this will become tree. Yes, but they have not connected, so this is a disconnected graph. All graph is disconnect, so this is not a tree. Okay, as a simple tree means it's a parent branch, then okay, leaves. Okay, just like trees, stick figure tree, or if you want to draw in graph theory, this is also a tree. Okay, uh, tree has a not containing any cycle. A tree should be connected. Okay, so it's called tree. Okay, so tree is undirected connected graph with the no cycle. Undirected means it says a vertex and edges. Undirected means we have discussed in I think third or fourth lecture that undirect graph is as a non-empty set of vertex and edge. Okay, vertex and edge should be more than one, it should not be zero. Okay, so undirected graph and connected graph with no cycle, so there should be three condition: undirected, it should be connected, and it should be no cycle. Okay, this is a cycle. Cycle means it's a come with the, we have started with the that vertex. Okay, so if this is a vertex, we if we make path or walk, we can move from this initial point, finish with the initial point, it's called cycle. Okay, so in this graph, this you can not make a path with the initial and finishing point as a one. Okay, so if we started this, we cannot come like this because there is a no edge joining between them. Okay, no cycle. Okay, it keeps branching out like a actual tree. Okay, it's keep branching out like, but it's not required to draw it branching out from the bottom to top like this. This is also a tree and this is also a tree. We will not require that it will come out this like this. Okay, it's a parent branch or like this. Okay, this is also a tree. Okay, it's the same property as a tree, actual tree. Okay, various types of tree are genealogical, evolutionary, decision. Okay, this is also used in computer science. This graph theory is also used in your computer science. Okay, now theorem: a tree has exactly one path between any pair of vertices. Okay, tree has exactly one path between any pair of vertices. Okay, like this, tree has only one path in any two vertices. Okay, you can see that there is only one path in any two vertices. Okay, how do we find out that this is true. Okay, let's say x and y be two different vertices. Okay, there is a path between them since the graph is connected. Okay, connected should so that there should be a two vertices is connected. Okay, so suppose there are two unequal path between them. One is red, one is blue. Okay, so this is are the vertex. Okay, this x and y should be connected. Okay, so now this red path is different path, blue path is different path. Okay, now you can see that there is a joining this vertex. If we make path or walk, you can see that there is connecting like this, and we can get the from initial to finish vertex. So this is a cycle, but we already discussed that tree has a not a cycle. Okay, so this should be different. Okay, so tree has a no cycle, thus there cannot be two paths between any two vertices. Okay, so their tree has exactly one path between any pair of vertices. Okay, if you pick any two vertices, there should be only one path. Okay, let's say this A and this is a B. Okay, so if you want make path like this, there is only one path. There is no another path you can draw. Okay, so in between two vertices there is only one path. Okay, one path between any pair of vertices. There is not two path between two vertices. Okay, if there is a two path, then it will become cycle, and in trees definition there is no cycle in between them. Okay, now leaves or leaf. Okay, in tree also we have leaves, actual tree. Okay, so leaf means a vertex of degree of 1 is called leaf. Degree of vertex is 1. We all know what is the degree of vertex, number of edges. Okay, for particular vertex. Okay, for this vertex degree of vertex is 1, 2 and 3. We just have to count number of edges. Okay, so in tree whose vertex has a degree of vertex 1, it's called leaf. Okay, this parent also degree of vertex is 1, so this was also a leaf. Okay, so there are this green is all the leaf which has degree of vertex as a 1. Okay, so there are 8 leaves including bottom vertex. Okay, sometimes vertex of degree 0 is also counted as a leaf. Okay, let's say this vertex. Okay, this is also counted as a tree, this is also counted as a leaves. Okay, why? Because there is a no edges joining them. Okay, and degree of vertex greater than or equal to 2, more than 1 or greater than or equal to 2, it's called internal vertex. Okay, it's internal. Okay, so this has a 3 degree of vertex, so it's internal. This has a also 3, this also has a 4. Okay, this has a 3 degree of vertex 3, 1, 2 and 3. Okay, so this yellow dot is a internal vertex. Okay, with degree of vertex more than 1 or more than or equal to 2. Okay, this is called leaves and internal vertex. Okay, next theorem. Every tree with at least 2 vertices has at least 2 leaves. Okay, every tree with at least 2 vertices means 2 or more than vertices. Okay, so there should be 2 more than 2 vertices. Okay, at least 2. Okay, there should be not be 1 vertices. Okay, now what theorem said that at least 2 vertices has at least 2 leaves, has at least 2 leaves. Okay, for the graph you can see that there is, this is also leaves, this is also a degree of vertex 1, this is also 1. Okay, you can see that there is a more than two leaves. Okay, but how do we prove that this theorem is true? How to prove? Okay, so let's say pick any vertex x. We have pick any vertex s. Okay, generate a path starting at x. Okay, we have to generate path. Okay, you can start from this also, or you can start from down also. Okay, we have started like this. Okay, you can go here also. Okay, it's your depend on, it's on you. Okay, we have just have to draw a path starting from x. Okay, so this is a path. Okay, then we can go down like this also, or we can go down like this. Okay, we can also go down up or down. Okay, so we have to make path till then that there is a no path between now. Okay, like this. Okay, now you cannot move from this vertex. Yes, you cannot go reverse. Okay, you cannot select path which you have already crossed. Okay, you cannot go. Okay, so we have draw one path. Okay, so now this z has a only one edges. Yes, so degree of vertex is 1. So we have now in tree graph that one vertex has a this one vertex has a one leaves. Yes, now start from z. Let's start from the, okay, so they have there is yes, path starting at x. There is at least two vertices, then graph is connected. Okay, x has at least one edges. Okay, so follow any edge on x to a new vertex. Okay, we have to go to the new vertex. Okay, then pick up with no unused edge. Okay, from we have now arrived at z. Okay, so degree of vertex from z is 1. Okay, because we cannot make any new path, new vertexes. Okay, so thus z is a leaf. Our for one vertex we have one leaf. Okay, then start with the over with the z for different path like this. You can make any path you can like. Okay, you have to just start with and do not stop until you cannot find new vertex. Okay, so we have now new vertex zf z dash. Okay, so this is also a degree of vertex 1. So this is also a leaves. Okay, so we have now for any vertex we have two leaves. Okay, so our theorem holds the true that every tree with at least two vertices at least two leaves, two or more than leaves. Okay, so from the this path we can prove this theorem holds the true. Okay, next, all trees on n greater than or 1 vertices have exactly n minus 1 edges. Okay, we do not have the this theory, we have to find out. Okay, in last semester in sequence and series we have studied induction theory, induction theorem. Okay, for the find out about this theorem is true or not. In that we have to first of all find out if it's true for the base n is equal to 1, and then we have to find out that minus 1 it's also true. Then if it is a this both step are true, then we can say that this theorem is true. Okay, like this summation of all the terms of 1 to n, 1 2 3. Okay, get the idea that it's a n upon summation. Okay, so we this for the find out of this theorem we have take two lecture of induction theory. Okay, so this theorem we will find out that from the induction theory, so that this theorem is true or not. Okay, proof by induction. So first of all we have to find out that base case is, okay, so let's say assume vertex n is equal to 1, only one vertex. Okay, so there only such tree is isolated vertex. Okay, we cannot draw any edges. Okay, if we draw edges then we have to make sure there is a two vertex. Okay, so there is a no edges. Okay, so no edges means zero edges. So for n is equal to one vertex, we have zero edges. So this theorem is true. Okay, for n is equal to 1, we have this theory holds the true. Okay, let's now find out that second step, that for n greater than or is equal to 2, assume that theory holds for n minus 1 is vertices. It's true. Okay, in induction theory we have to assume that n minus 1 vertices, this theorem is true. So for n minus 1 vertices, now we have n minus 2 edges. Yes, induction theory. Okay, so let's take a G graph, or a G be a tree of n vertices. Okay, now pick any leaf. Let's say assume we have picked this leaf. Degree of vertex 1. Leaf means degree of vertex 1, V. So edge E, V and W vertex be its unique edge. Only one edge. Now remove V and E from the graph H. Okay, we make subgraph of H. Okay, now we have to find out that this H is a tree and also has a n minus 1 edges. Okay, so let's say H is connected. Yes, this is a connected. H has a no cycle. We can see that there is a no cycle. Okay, if it is a cycle, then G also has to be cycle. If it is a cycle, then it's called not to be a tree. Okay, we have first to assume that G is a tree, so it's a no cycle and connected. Okay, so now H is a tree with n minus 1 vertices. You can see that. Okay, so induction hypothesis, we have n minus 2 edges. Okay, we have removed one vertex. This is a n vertices. We have removed one vertices, so we have now n minus 1 vertices. Okay, now our second step, we have assumed that for the n minus 1 vertices, this theorem is true. So H has a n minus 2 edges. Yes, okay, so by induction hypothesis, H has a n minus 2 edges. Okay, so if this has a n minus 2 edges, this graph H graph has a n minus 2 edges. Okay, so for making of this subgraph, we what do? We have remove one graph, one edges. Okay, so for this graph, count of this edges, we have to add one edges. Yes, so we have now n minus 1 edges, which is true, which is our theorem is true. Okay, again, so let's say this has a assume that this is a n vertex. Okay, for this edge we have removed one vertex, so this graph should be n minus 1 vertex. Okay, now in our step 2, we have assumed that theory is true for the n minus 1 vertex. Theory is true for the n minus 1 vertex. Okay, so n minus 1 vertex, so n has vertex and exactly n minus 1 edges. So we can say that this H graph has a n minus 2 vertex. Yes, this graph has a n minus 2 edges. Okay, for assume that this is statement is true for the n minus 1 vertex. Okay, so now we have now arrived that this graph is a edge of n minus 2. Okay, so now we have removed one graph to become this graph. Okay, so if this graph has n minus 2 edges, so if you want to find out that this graph, how many edges are there in this graph, we just have to add one edges, which we have removed e edges. Okay, so we have now n minus 1 edges. Okay, so our step 2 also true. Okay, so our step 1 is true, step 2 is true, so this theorem is also a true. Okay, so all three of n vertices has exactly n minus 1 edges. Okay, you have to remember this. All the trees of n vertices have exactly n minus 1 edges. Okay, now next theory, lemma theory. Removing an edge from a cycle keeps connectivity. removing edges from a cycle. Okay, cycle, this does not talk about tree. There is a one graph that it is a cycle. Okay, if we remove edges from that cycle, okay, but then this will become tree also, or the connectivity also keeps. Okay, let's say this graph is a this red dotted line is a cycle. Okay, we have started from the first and ending with the same vertex. Okay, okay, now let's okay, now if we want to move from y to vertex x, okay, so there is a path like this. Okay, now let's remove these edges from cycle. Let's remove these edges from the cycle like this. Okay, so now if we want to go from y to x, we can go make a path. Yes, we can make like this path also. Okay, so if we, and here you can see that if we remove any edges from the cycle, we can from one vertex to next vertex we can go. Okay, keeps connectivity. Okay, so it's become large, more length, but we can move from y to any other vertex. Okay, so we can rewrite the path to substitute e. So okay, so we have now, we can keep the connectivity if we remove one edges from the cycle. Okay, this is called lemma theory. Then next, spanning. Okay, a spanning tree of undirected graph is a subgraph that's a tree and include all vertices. Okay, include all vertices. Okay, this is a undirected graph. Undirected graph means it has a non-empty set of edge and vertex. Okay, so now if we make the subgraph of undirected graph, it's called spanning tree. Okay, now graph G is a spanning tree if it is a connected. Okay, so any two vertices have a path between them in the spanning tree and hence it G. Okay, let's say assume let G be a connected graph of n vertices. Okay, if there are any cycle, here we have two cycle, red and blue, pick one and remove any edges. Pick one cycle and remove any edges. Repeat until we arrive at a subgraph T with no cycle. Okay, we have to transfer this graph into a subgraph that has a no edges. Okay, now let's say assume here they have removed these edges. We can remove any edges. Okay, now let's say take second cycle. Okay, they have removed this edge. Okay, so now we can see that there is a no cycle. T is still connected, so it's a tree. It's called a spanning tree and it reaches all vertices. Okay, so from any graph if we remove edges from the cycle and make new graph, new subgraph, and it's also has a no cycle, it reaches all vertices, so it's called a spanning tree. Okay, so we just have to make sure that we can transfer graph into a tree. Okay, so let's assume we let's take we have removed these edges. Okay, and then these edges. Okay, we can make like this. Yes. Okay, in this graph let's assume we have removed this. Okay, so this. Okay, then here this, that, and that. Okay, this is also a tree. Okay, so if you remove any cycle, any edge, one edges from the cycle, and it's always become it's if it is a tree, then it's called spanning tree. Okay, so now for this lecture is completed. Okay, so for the assignment, you have to draw any graph with the cycle. Okay, and you have to delete the edges from the cycle and make a spanning tree. Okay, you can draw any graph with the cycle like this G. Okay, and you have to make the tree, spanning tree, from removing edges from the cycle one by one. Okay, you have to draw minimum two cycle. Okay, and next question is like this. You have to make any graph that is a cycle, and you have to find out that lemma theory is true. For if you remove one edges from the cycle, you can still continue connectivity. Okay, so this is your two question and upload it in RediNet application. Okay, so now today's lecture is completed.